Amresh, could you bring in the... Hello and welcome to today's discussion. I am Abhay Vaidya, Associate Director, Pune International Center. Last month, a landmark study on estimates of COVID-19 mortality in India was in the headlines because it set to rest our suspicion and doubts about the official data on the mortality. This study by Professor Arvind Subramanian and his fellow researchers, Abhishek Anand, Justin Sanford, was titled Three New Estimates of India's All-Cause Excess Mortality During the COVID Pandemic. The authors, in an article in the Indian Express on July 20, expressed the hope that confronting the scale of the tragedy will help India draw lessons and etch them deep into the nation's collective consciousness to foster a never-again resolve. We are honored to have with us Professor Subramanian, who is connecting with us from the United States, and Professor Ajit Kembavi, eminent astrophysicist and principal investigator, Pune Knowledge Cluster. Welcome, Professor Subramanian and Professor Kembavi. A friend of PIC, Professor Subramanian is well known as the former economic advisor to the Government of India during 2014 to 2018. He is currently senior fellow at Brown University, Watson Institute for International and Public Affairs. Professor Subramanian is also distinguished non-resident fellow, Center for Global Development, and non-resident senior fellow, Peterson Institute for International Economics. Professor Ajit Kembavi is an eminent astrophysicist and emeritus professor at IUCA, the Inter-University Center for Astronomy and Astrophysics. Professor Kembavi is also the principal investigator of the Pune Knowledge Cluster, which seeks to bring together academia, R&D institutions, and the industry of Pune region to address the challenging problems of the region through innovation and scientific knowledge. Pune was one of the COVID-19 hotspots in Maharashtra, and the PKC has been engaged in the battle against the COVID-19 pandemic. Professor Kembavi, I'm sure, will tell us about that. I shall now request Professor Kembavi to present his opening remarks and then invite Professor Subramanian to present the highlights of his study. You are welcome to post your questions in the chat box, which will be addressed by our guest speakers. Professor Kembavi, the floor is yours.
Thank you very much, Mr. Vaidya. I'm very glad to be introducing and talking about here to say a few things, chairing the session in which Professor Arvind Subramanian will be speaking. As I just said to him, it's a little bit ironic that an astronomer is introducing an economist who's going to be speaking about an epidemiological topic. So COVID has done many bad things for all of us, but it has managed to bring together people from diverse fields to work together to try to get rid of the pandemic, or at least to understand it better so that we can mitigate all the difficulties that it causes. So yesterday, for example, there was a brilliant lecture on COVID data gathered in Pune over the last 18 months or so by Professor Joy Melvin Montero of IISER Pune. And he's an atmospheric physicist, okay, who's, as he says, spending about half his time on analyzing COVID data. It's also a great good thing that the discussion is taking place in Pune in a certain sense. Professor Subramanian is sitting in the US, but that is how things are these days. For all practical reasons, he's here with us. So because Pune has been at the forefront of gathering and analyzing COVID data, we have limited it to the city of Pune and the Pune region. The data has been provided very generously by the Pune Municipal Corporation, which gathers it from various hospitals and other sources. And then it has been analyzed by people, curated very importantly, and then analyzed by people in several different institutions, including NCL, IISER, Pune University, and several other organizations in Pune. And the Pune Knowledge Cluster has been facilitating the interaction between different institutions and also contributing its own expertise in a small way to the effort. So, Professor Subramaniam has already been introduced, and in fact, he does not really need an introduction. We most famously know him as the Chief Economic Advisor to the Government of India in 2014 and 18. So, he and his colleagues have written this paper on the three new estimates of India's all-cause excess mortality during the COVID-19 pandemic. There's Abhishek Anand, Justin Sandifur, and Arvind Subramanian. And then they are very helpful to also provided a very nice, very readable summary in the Indian Express Explained page, from which I first learned about the paper. Now, what they say there is now universally known. It is estimated by official sources that about 400,000 deaths which have occurred because of COVID-19. It is also believed that these are underestimates. And then, it's very important for us to understand, or at least try to get an estimate, however nebulous, of the correct number, put error bars on it. And that is where the long-standing expertise of Professor Subramanian has come into the picture. And he has done a wonderful job of this analysis. The numbers are still uncertain, but it seems to be established beyond doubt that the real number of deaths is much larger than what the figures tell us, what we see on TV every day, for example. Okay, so which are official figures. And that is not necessarily entirely because of fudging of data or whatever. It can simply be because of the difficulties of gathering data. I used to believe that it would be the easiest thing in the world to just find out how many people have died in different places and add the number up together. But that is far from easy. And even in normal times, when there are no anxieties, there are a lot of uncertainties, uncertainties regarding this number. And those become much sharper in the current times. It is very important for us to know what the real numbers are, to estimate them, as Dr. Subramaniam will explain to us now. First, he will give us a recap of the paper, and after that, there will be a discussion. And I hope all of you join in by sending your questions. Thank you. And now, Dr. Subramaniam, I invite you to begin your discussion.
First of all, I want to thank Dr. Vaidya, Professor Kembavi, and the Pune International Center for inviting me to come and speak at the Pune International Center. I think it should be no secret to anyone that one of my gurus and intellectual inspirations, supporters, has been, the great Dr. Vijay Kelkar. So anytime, he says, Arvind, please come and present, I feel honored to do that. And so, and just to refresh people's memories, I think the first ever talk at the Pune International Center, I had the privilege of, presenting, if I'm not wrong. So it's wonderful to be back, and thank you very much for inviting me. So what I'm going to do, I checked with Vijay last night, my time, and just to ask whether having a PowerPoint would help. So I am going to present a PowerPoint. I hope it won't get too technical, but I think it just kind of helps understand the thing a little bit better. And if there are any confusions or clarifications, please feel free to direct them to Professor Kembavi or in the chat box, and I'd be happy to address them. So this is, of course, joint work. My co-authors have done as much, if not more, work than me, and I want to acknowledge Abhishek Anand and Justin Sandifur. It's been a joint effort. It's been many, many months in the making. And we call this 3 estimates of India's all-cause excess mortality for reasons I'm going to explain. I want to begin with this chart. It's a chart on the right-hand side, which shows total excess death per million people which is the Financial Times. This was done as of May 5th. So the data there are as of May 5th. And as we know, the official count in India as of end June was 4 lakhs. But I think, it's very important here to understand kind of what is the right number one has to have in mind in order to be able to think kind of intelligently about, the magnitude of deaths. Now, if you have a big population, obviously you're going to have more deaths. I mean, all else equal. So that's why this chart on the right-hand side shows excess deaths per million people. You can express it as per 1,000 people, which is how it's conventionally done in demography. So what the chart says is that ranks countries according to how many excess deaths in the COVID era per million people. And as you can see, Peru is right on top. And there are countries like Australia, Taiwan, Singapore, which did very, very well, which are right at the bottom. And some countries seem to have even negative excess deaths. If you were to take India's official death count of about 4 lakhs at the end of June, then you see that bar at the arrow and the bar, India would be at near the bottom, or i.e. very successful countries in having avoided excess deaths. I mean, almost as good as Israel, for example. But that it immediately says that's a huge puzzle. How can India have so many fewer deaths per capita when its infection rate we know is so high, almost 70%, and I'll come to that. So how can it be that your infection rates are so high and yet your deaths per capita are so low? And that's kind of, for me, was kind of the motivating puzzle about India. If India were like, so in a sense, before the before the second wave began, before we became alert to what the higher numbers were, we had a sense in India, even around March of 2021, that we had escaped the worst of the pandemic. And that's why there was complacency and triumphalism. And it was a bit based on this official number saying, look, we are so low in terms of deaths and deaths per capita. And there were plenty of articles also saying, how come India has done so well? But then, of course, we've discovered that there's no kind of, because for every other country in the world around that time, there were lots of estimates of excess deaths, because everyone realized that actually the official deaths could be underreported for many, many reasons. And as Professor Kembave said, I mean, it's not because people are fudging the data or whatever. It could be because of genuine difficulties in getting the right data. So if even today, for example, India is one of those countries. So in the chart that I showed you, this chart, India doesn't feature because there were and there still are no detailed official estimates of true excess deaths during the pandemic, because India hasn't produced these numbers. There are lots of model-based estimates. The International Health Metric Institute for Health Metric Evaluation, The Economist, Professor Brahma Mukherjee from Michigan. Lots of people have done, model-based estimates, but there were few data-based estimates at an all-India level. So when we wrote our paper, that was the background. There were no, good excess death estimates at the all India level. And of course, as we know, the official death estimates produced by the Government of India Center, it's called the SRS, sample registration system. It's an offshoot of the census. And those data that were lagging by 2 to 3 years only have that up to 2019. But when the second wave happened, all that changed. And really, it's a tribute to Indian civil society, really, that when the second wave happened, we started getting compilations of deaths, from crematorium, from hospitals. And then thanks to the fearless, intrepid, tireless work of many newspapers, Gujarat Samachar, Sandesh, Saurashtra Bhaskar, Dainik Bhaskar, Hindu, and many, many journalists, Rukmini S., Srinivasan Ramani, Arunab Saikia, Dhanya Rajendran, Tejesh, Maria Malavi, Sovir Das, Chinmay. It is to the credit of people like this that researchers like us have been able to, in a small way, build upon this terrific work to come up with these estimates. And then simultaneously, what happened was that some of us, Anup Malani and Sabarish, we discovered that there is a kind of independent source of data on deaths, which is the Center for Monitoring of the Indian Economy, CMIE. They have this, every 4 months, they interview 177,000 households. And people discovered they also ask a question about deaths. And so that also provided a kind of alternative way of estimating excess deaths. Now, I want to, be very clear about the caveats and the spirit in which this is done, because I think it's important, especially in this era of polarization. All kinds of motives are imputed to people, and so I just want to be, clear, what the caveats in this work are and what was the spirit in which it was done. First of all, we are not measuring COVID mortality. There's one estimate that is kind of gets at COVID mortality, but generally we measure all-cause excess mortality. So essentially, what we say is, what were the deaths in 2020 and 2021? What were the deaths in the previous period, and what's the difference? And that's called the excess deaths. And it's due to all causes, because it's very difficult actually to say what was actually due to COVID and what was due to other reasons. And we can go into why it's very complicated. Even advanced countries have difficulty doing that. That's point one. Point number two is that, given that official data are lagging behind, all data sources, all methodologies have problems. And Professor Kembavi put it really very, very well when he said that, look, there are lots of uncertainties, there are lots of problems, and so there's no one source or methodology that's the best. There's a lot of uncertainty. We should always be providing confidence bands. So the question is, in the face of these challenges, should we just wait and give up? Or should we actually do something in terms of actually counting? So our spirit is very much in the spirit of the scientific method. It's precisely because no one source is good. You use all possible sources available. Be absolutely transparent on assumptions and methodology. Be aware of the biases and limitations. Be very careful about conclusions. Specify how much uncertainty there is. And of course, in this true spirit of the scientific inquiry, let 1,000 flowers bloom. Ours is only by no means the definitive or the only work. There are lots of other work. And there's a famous saying, which is that, science progresses, one funeral at a time. And it sounds a bit crass in this COVID thing to say that, but in the scientific method process, maybe others do it better, and then we should, see this as an ongoing process of trying to, come up with some better, not the best answers, but better answers. I think it's very important to realize that, this is something we have to do. We cannot not do this because, data are uncertain. There are problems with all of this. Firstly, we owe it to all those who have died and, those who have suffered watching their relatives die. I think there's a deep sense in which we owe them to kind of that, acknowledge that this has happened. Stalin famously said that one death is a tragedy and 1 million deaths are a statistic. And I think we should really try and avoid that. We should try and come to grips with this. And also because we have to learn the right lessons in terms of how to improve our responses, both today and going forward. So I've been spoken a lot. Let me just get now to the. So we use 3 different sources and different methodologies. The civil registration system, which is basically states compiling the data on deaths. Then we use a second method where we use Indian seroprevalence studies, i.e. there have been very good Indian studies on what is the infection rate nationally. So we combine that with international estimates of how many people die conditional on how many. So the infection rate tells you how many people are infected. The infection fatality rate tells you for every infection how many people die. So we combine these 2 data and come up with a number. And the third, as I said, we use the CPHS CMIE data. Now, I want to acknowledge that lots of other studies simultaneously and afterwards. Anup Malani, Sabrish Ramachandran, Murad Banerjee, who's done excellent work, along with Ashish Gupta, who's a demographer as well, and then Prabhat Jha, Chinmay Tumbe. They've also done a lot, tremendous research, and I think we should follow the work of all these people. So our bottom line is expressed in this table, which was in the newspaper. So you see the 3 methods, the 2 waves and the total. And so what we say is that roughly the civil registration system gives you something like 3.5 million excess, all-cause excess deaths. Our second methodology gives about 4 million. Using the CMIE gives you a slightly higher number of close to 5 million. So the range is between, 3.5 to about 4.5, 5. And of course, I'm going to tell you what the assumptions are. Each of these estimates themselves have uncertainty, and that's what I want to talk to you about. So for us, if I would say the 2 big takeaways are, one, probably the true excess deaths were probably somewhere between 3 and 5 million. Probably 3.5, 4 would be a plausible number. That's much greater than the official count. And second, of course, that the one new surprising finding for us was that wave 1, which we define as between April 2020 and March 2021, was higher than we believed. And my sense is that complacency that we all, I mean, this is not just government, all of us fell into, to be honest, was because we thought the first wave was less lethal. We escaped it somehow. And I think that was a little bit unfortunate. Maybe the first wave was more dangerous than we believed. And that for us was a new finding. So now I'm just going to explain what did we to some extent. So the problem with the civil registration system, firstly, I'm going to show that, by the way, these numbers that I've presented here are an update of our paper. For example, in the civil registration system, when we did the paper, data was available only for 8 states. Today, it's available for 13 states. 13 plus or minus 1 or 2 for reasons that, for some states, only the first wave is available, not the second wave. So we know the problems with the CRS. Historically, it has undercounted deaths. In 2018, the undercounting was about 15%. But even that may be on the low side, because we know from the National Family Health Survey that the undercounting is even greater than what is suggested by looking at the state's civil registration system. And there's no real pattern to this. It's been varying across time, across states. What we do find is that there's a trend improvement in the accounting. More and more are getting accounted for, but there's still a lot of uncertainty. The other thing I want to say is that the data that we have out of the 14 states, for 2 states, only for 2 states do we have data for June. So the numbers that we've come out with and others on the CRS is still an undercount, because we don't have June data for most states, And we know June, July, given the lags in counting, are going to be months with pretty high deaths as well. So I think that's what we should be aware of, that it's not perfect, this data source. It's been undercounting, a lot of uncertainty about where it is. And so what we do in the paper is we're very frank about saying, look, how do we go from these 13 states to the national population? Because we do measure all India numbers, the numbers that I showed you, 1.8 in the first wave, 1.7 in the second, 3.5 overall. We make some assumptions about, first assumption, we undercounted in the past. That same undercounting continues in the future. That's our baseline. You could have another situation where you say, for some miraculous reason during the COVID, all the undercounting was eliminated. That would give you a much lower estimate for undercounting. And so you have to make all these assumptions, and we think in the baseline, it's about 3.5 million. There is some tentative evidence to suggest that actually undercounting has once again gone up, because you would expect that these data systems actually are under more pressure during COVID. There's some evidence, for example, that birth registrations in the few states for which we have data have actually fallen in the COVID period. So it's more likely than not, although we'll be sure, that the undercounting problem worsened during COVID, in which case our numbers would be a bit of an underestimate as well. And they're also, of course, underestimates because we still haven't captured June and July. I want to just show this chart for the 13 states. Remember, for Uttar Pradesh, we only have 1 month of the second wave. So I like to look at the second wave without Uttar Pradesh. So basically what we do is that all these states, we compile, and then what I want you to focus on is on the last column on the right. Essentially, the worst affected states measured as excess deaths per capita or per 1,000 people: Chhattisgarh, Andhra Pradesh, Bihar, Madhya Pradesh have been amongst the worst hit in COVID, and Karnataka. And these numbers of 4.6 per 1,000, 3.08, 5.8 per 1,000 are the excess deaths for the whole COVID period from April 2020 to May, June 2021. Now, just so that these are numbers that don't just so that they mean something to you. In India, all India, in normal times, 2018, 2019, 2017, etc., roughly we have 7 deaths per 1,000. About 10 million people die in India every day. So that 7 per 1,000 is the baseline mortality, and the numbers in the last column you're seeing are therefore relative to that. So all-cause excess deaths in Chhattisgarh, 5.8 per 1,000. Let's say baseline is 7 or 8. So that's the amount excess that has happened during the COVID pandemic. Uttar Pradesh still hasn't come in. So my sense is that we're likely to see slightly higher than what we're looking for. The second estimate, which is that, it's a very simple arithmetic. Deaths upon population, which is the deaths per capita we're measuring, is how many infections there are and how many deaths per infection. And so if you look at the right-hand side, the infection is measured by seroprevalence, and the infection fatality rate, i.e. how many deaths per infection. The problem is that you can't get that from Indian data because the basic problem is deaths are undercounted. That's why I've highlighted that in red. So in a sense, to come at a kind of macro number on deaths per population, we need macro infection rates, and India has done a very good job on the seroprevalence. But how many deaths happen per infection, we need some other way of estimating. And what we do here is we get international data on these infection fatality rates, i.e., how many deaths per infection, and not how many reported deaths or official deaths, which is called case fatality rate, but how many true deaths for infection. So what has happened in India, one very good thing is that we now have 4 national seroprevalence surveys. And what you will see, the latest was released in end July or early August. It was done for end June. And what you find is that there's a steady progression. If you look at the 4 national seroprevalence surveys, they steadily increase in a very kind of logical, consistent fashion. The third one done for end December said 22.5. In March, there was a WHO AIMS said 58 to 63. And the 4th prevalence survey said something like 68 overall and 62% amongst unvaccinated people. So these are very kind of plausible numbers on seroprevalence. So what we then do is that we take these seroprevalence rate, but we need international numbers on infection fatality rates. So what we've done, just to be completely transparent, is that the CDC in March 2021 said it published its best estimates of age-specific, i.e., for every age category, how many people die given that they're infected. So what we do is that we get those age-specific infection fatality rates and apply that to India's demographic structure. Because remember, India has a much younger population. So if you say, for example, around the world, if you're 50 years old, there's a X% chance of dying if you get COVID. Then because there are fewer 50-year-olds in India relative to the US, overall the infection fatality rate in India is going to be lower. So we do account for India's demographic structure, but the age-specific number comes from the CDC. The CDC itself is based on an analysis of 2 or 3 meta-analyses that were done. So we looked at all these meta-analyses and looked at some other ones as well, and decided that the CDC numbers are plausible. And so we estimated, just multiply the infection rate times the infection fatality rate. We estimated the infection fatality rate for India as 0.5%. This is that on average in India, if for every 100 people, 0.5 would die if you get the infection. So we say wave 1 is 1.5, wave 2 was 2.4, and so total about 4 million. So now notice that the first method and the second method are giving you broadly similar numbers. Now, the one thing I will say is that this number on the infection fatality rate, 0.5, some would say for India it's lower, somewhere between, say, 3 to 0.45. But we looked at this evidence carefully, and it seems to us that even if in the first wave, the infection fatality rate is, say, lower than 0.5, I think in the second wave, it is likely that this was much higher. And why do we think the second wave it was higher? For the simple reason that there was tremendous pressure on our health systems, ventilators, oxygen, beds, etc. And because the second wave, A, happened with a more lethal virus, B, happened in a much shorter space of time, so it strained capacity much more than in the first wave. That's why we think that the fatality rate is going to be higher in the second than the first wave. And we don't, so to be on the conservative side, we don't use that. We just use the average for the period as a whole. So for example, there's data from New York that in the 4 to 6 weeks, March, April of 2020, when the systems were strained, the infection fatality rate jumped almost threefold because of the pressure of the health systems. So if we think even in New York, with all its high tech and capability and health systems, it must have been the case that in India, So that's why all this is a way of saying that we're trying to err on the side of being conservative and not, being excessively alarmist. So that's the sense in which you should view this number as, another plausible number. So 3.5 million from the first method, 4 million from the second method. And as I said, there are caveats associated with this because we still don't know for sure what is the Indian infection fatality rate, because we don't, and in a sense, we can't do that because we don't have good estimates for deaths per se. So we are forced into, trying to get other sources to come. So that's the kind of second way of doing it. The third way of doing it is a bit more controversial because it's based on this Consumer Pyramid Health Household Survey. Now, this survey, to be fair to CMIE, it's done mostly for estimating consumption, employment, unemployment, labor force participation. So they never set out to measure deaths based on this, but they do ask for death data. And so it seems like, and it's the only panel data that we have going back, since 2015, and 177 households are surveyed. So, and it's almost up to date. We have data almost up to May, some of it for June as well. So some of us have said, let's just see what the numbers show. We're not going to say this is the best way of doing it. Let's see what it's giving us. And that's why, we use this data. There's a lot of controversy about the representativeness of the CPHS. Jean Drèze and his co-author say it kind of samples to urban and richer people, which is possible. And also here, we want to be careful about, if there are any biases in the sample, can we adjust for that when we estimate our number? Now, I don't want to go into all the details on this. This is what you get if you go back from January 2015 to the latest to June 2021. What you see is that on the y-axis is the death rate, annualized death rate. And remember, the number you have to keep in mind is 7. India gets 7, and see this dotted line is at 8, which is the kind of average. So that's why, I'm going to talk about this in just a second. So keep that in mind. So you see the mortality rate jumps, drops in 2019, picks up in 2019. And then you see the yellow and the red line, wave 1 and wave 2, it kind of, death surge. So the question is the CMIE data reliable enough for us to be comfortable with estimating excess deaths in the pandemic? And there are 2 reasons to be very cautious. First reason is, as you can see, we've done other work, which I'm not sure, which is in the paper, that if you try and validate the CMIE pre-COVID number, from January 15 to say beginning of 2020, it doesn't track other data, official data, all that well, either at the state level or at the age-specific level, etc. So one has to be a little bit cautious about that. But I think the more serious kind of a caveat here, you'll see that the red circle line, this data seems to show that there was an increase in mortality even before the pandemic began. And that's a bit worrying because we don't know, it's inexplicable. And that's why I think when we made estimates based on this data, we tried to be very careful and come up with, take account of some of these deficiencies on the data. And that's what gave us the number that you saw of about 4.5 to 5 million from this data. So I think this data are still, people are working on it. And so we have to take it with the caveats. But I do think that this is a valuable source of data, which we should use in some way or the other. We shouldn't just discard this because, there's some problems with the data. And so I think we should use that. But just to kind of summarize, is that all of them have their deficiencies, but, we can be transparent. And we can, try and triangulate to come at a reasonable number. And so our overall conclusions are that the first wave may have been more lethal than believed. I just mentioned that. But it certainly seems to be the case that the true number is closer to somewhere between 3.5 and 4.5. And it's an order of magnitude greater than the official count of 400,000. Now, when you say, 40 lakh people died in India from COVID, and people say this is alarmist, sensational, how can it be? It's very high. I think, again, we should be careful in understanding what is high and what is low. Because remember, if there are more people, there are going to be more deaths. So in a country such as ours, this is going to be happen. And so one way of understanding whether India's numbers, the true numbers of, let's say 40 lakhs or 45 lakhs are high or low, is again to go back to that chart. Remember, the official number is the bottom arrow, India official. It says, our performance was like Israel. But if you look at more like the true numbers that we've estimated and others have estimated, and by the way, the other studies that I mentioned, all of them are very much in the similar range to ours. Murad Banerjee and Ashish Gupta, Prabhat Jha, Chinmay Tumbe and others, very much in the 3 to 4 million range. But again, so if you look at the official, India seems like did very well. But if you look at the true number, and that's the arrow on top, no, India is not amongst the worst. It's high, but it's not amongst the worst. India is somewhere, it's still probably done much better than many of the Latin American countries. But, a number of something like 40 lakhs to 40 or 35 to 45 lakhs is a number that says India, did not.
We have lost the connection with Professor Subramanian. We'll reconnect with him soon. Professor Kimberly, would you like to share some information about the work done by Pune Knowledge Cluster on the COVID front?
So, as I said, what we have been doing is collecting the data, which comes in rather heterogeneous form. And then that data is all to be combined together. There are 3 kinds of data. One kind which is totally open, which is the number of events which occurred on a given day. How many people were admitted, how many people are serious, how many people died, and so on and so forth. And the PMC puts out these numbers quite openly. Then there is data which is on patients. Okay, so which is that who was admitted to which hospital on what date and what happened to the person subsequently, and so on and so forth, about the address of the person. So this involves issues of privacy, and it's very important to anonymize the data. And the third kind of data, which is probably the most important in the long term, is clinical data. Okay, where you say that you take a certain number of patients and then you follow them, and then you see how are they treated, what happened to them, and what are the subsequent development in the patient, clinical developments in the patient. And so the PKC, and when I say the PKC, it is really a large number of investigators and a large number of institutions have access to all 3 kinds of data. And the data, as I said, comes in a very heterogeneous form. There are many errors in the data collection. He's back.
Sorry, I got unplugged. But luckily, I'd almost. Let me just finish. Can I just finish one last?
Yes, sir. Please go ahead. Please go ahead.
So I just want to say that, conclude by saying that, I'm hoping very much that there will be more research on this. That we should be, this is by no means the last word or the definitive word. Still a lot of uncertainty, but I think we do need to come to grips with the fact that the actual mortality in the COVID was much higher than the official number. I mean, again, it's not the undercounting is not fudging or not the fault of any one party. I think the message seems to be that our systems need to be improved. Of course, a really bright spot in this is how robust Indian civil society, journalists, researchers have been in allowing all of us to do this. So I would say even in these clouds, I see that silver lining of how robust Indian society still is, that we can do these things in ways that may not have been possible otherwise. Sorry about if I've been too long. Sorry for the glitch, but let me stop there, Professor Kembavi.
Yeah, thank you very much. I was just saying some things in your absence that are not important, but I should say that we are sorry that you stopped too soon. Okay, because you have been providing a very brilliant summary of an important but rather difficult to read paper. Okay, so many people would have liked to know what is in this paper, and they would have reading the paper might not be easy for everyone. And what you have done now is to lead people on to the most important conclusions. Right, so it's very, I think that it seems to be that many groups are coming out with these numbers. And of course, there are other groups which have come out with smaller numbers. But I have a question there. It's something which it's slightly difficult to put, but let me say it like this. Let me say, for example, when there are other kinds of disasters, then people would like to really know what is the real scale of the disaster and how many people have suffered, how many people have died. And in fact, on occasion, one tries to blow up the numbers a little bit because the aid that you get, which is very, very important to get the aid, okay, for reconstruction depends upon how great was the damage. Now, in this case, let's say that I'm running a state and I'll be interested in saying that the numbers are not very high and they're coming down, because that shows the efficacy of the procedures that the state has been adopting to mitigate the problem. Right, so I said numbers are small, numbers are small. On the other hand, if you seriously underestimate the numbers in that process, you're losing something, right? Because large numbers of people are dying. There is a personal and emotional cost. If my near and dear people are passed on, I would like them to be counted, not to be forgotten. But on the other hand, I'm sure that there's also a major economic cost. I mean, you said that, see, if we had estimated the numbers correctly for the first wave, then we might have been better prepared for the second wave. Now, at least we should be prepared for the third wave, not on the basis of 400,000 deaths, but on the basis of the correct number of deaths. But also, as I said, there could be things like economic costs, etc. So maybe it will help to enlighten concerned authorities on these matters. Is that we are not simply saying that you are not doing your estimations correctly. There is great importance to be attached to getting the estimations right, because all subsequent things depend on that. So if you could enlighten us a little bit on that as an economist, I think that would be very helpful.
Professor Kemble, I think that you make a very good point that, had we had a better sense of the epidemic, even I think, both the health as well as the economic responses may have been different and better. I think that, and here I may be wrong, that, the fact that we got complacent, and this is just a question more than an assertion, because, I'm not, in the corridors of power. I don't know what the thinking was. But my sense is, just from the outside, is that the kind of mission mode that we should have got on the vaccination drive, early on, I think that was to some extent weakened and dampened by the sense that, oh, we're kind of escaped the worst, and therefore I just feel that maybe the zeal and the intensity of the vaccine effort might have been different had we counted the numbers right. And I think that's probably the one biggest thing that I think was a consequence of the undercounting. In terms of the economic policy responses, I think that had we known there was more hardship, maybe the amount that needed to be pumped into the economy, this whole lives versus livelihoods debate that we had early on, that the sense, if we had a sense that the pandemic was much greater, maybe we'd have done a bigger policy package in response, maybe more cash transfers, more into health systems, and so on. So I think, again, there are going to be many, many other dimensions, but I think the two big ways in which not having accounting correctly or undercounting is one, how much kind of momentum we lost on the vaccination drive, and the scale of the macroeconomic policy response, I think may have been different and probably greater had we known how much. So that's we could debate this. There could be many others, but I think these are the two big ones, I would say.
Thank you very much. I now invite the participants to send in their questions so we can have a wider discussion. Abhay, you are muted.
Sir, there are some questions in the chat box and the question box, which would be accessible to you and to Professor Subramanian also.
Yes, I can see them. I can read out one question here, which says, is there data on estimated number of infections versus the reported number of infections? Does the deaths infections ratio differ between, say, the US and India? And if it does, why might it be so?
Yeah, we know that the official and the true infections in India, we know because we know the official infections. For example, today, I think as of August 24th, or let's say in end June, the official cases in India were 32 million, I think 32 million was roughly, and we know from the seroprevalence study, the kind of better estimate of the true infections, which was like 68% or something like 800 million cases. So that we know that official to true infection from our seroprevalence studies. Is that very different than the US? Yes, very different, because in the US, the true deaths and the reported deaths are much closer. For example, at the peak, the discrepancy was something like 20%, 25%, whereas in India it's off by a factor of 8 or 9. And also because of greater testing, the actual infections and the true infections were also much closer. So in many advanced countries, both the deaths and the infections, the true and the official, were much closer. In the case of India, both were very far apart.
Sir, you are mute. Professor Kembavi, you are mute.
Are there any more questions from the audience? And please feel free to make comments and give questions. And meanwhile, I'll ask you one more. Is that when you take a thing like the infection fatality rate, it's obvious that if you have excellent medical facilities, you're less likely to die than if you don't have such facilities. And so that you need to do that normalization when you take in data from one country to another country, I suppose.
Professor Kembavi, that's a very good point. It's a very fair point. But that is why I think that applying, applying an advanced country estimate to India could be off because of demography, and that we've adjusted for, right? But your point about the age-specific IFR itself could be different, but to be fair, it can go both ways. Because remember, early on in the pandemic, we thought, or some people said, that because of BCG and other vaccinations, Indians had some natural immunity to the COVID. So that would mean that an advanced country estimate is too high for India because maybe we have some natural immunity. And remember, there was natural immunity, there was temperature, and people said that would happen. On the other hand is the point that you just made, that because health systems are worse and comorbidities in India like diabetes and things are also maybe slightly worse, the infection fatality rate would be higher in India. So it could go both ways, but I think because the bulk of our cases, remember, end March, seroprevalence was 25%. End June, seroprevalence was close to 70%. And that second wave was the Delta wave. It happened in a very short time and pressured our health systems. So that's why I feel that the infection fatality rate assumption that we made also errs maybe on the side of being a bit conservative and a bit low.
I also feel that there is a point of arithmetic here, which is in the favor of not being affected too much by the IFR. It is that there's a very large number of people who are infected remain undetected or asymptomatic. So only a small fraction, a relatively small fraction, actually become active cases and get to hospital. Okay, and a small fraction of those die. Right? So therefore, the miscounting is limited because of these numbers. That's what I feel. Right.
There's another question about the third wave in India, on Maharashtra as well. So the question is, if the estimated deaths in second wave, Dr. Sati, the question is, it's not that the estimated death in the second wave was around 4 million. The estimated deaths in both waves was 4 million. And in the second wave was probably closer to 2 to 2.5. What would the third like? Will it be even larger? For example, Maharashtra government says third wave, we're looking at 6 lakh cases per day. Now, Dr. Professor Kembavi began by saying that an astronomer is introducing an economist to talk about epidemiology. The reason so far I felt comfortable and we felt comfortable doing our research was because we were almost entirely in the field of data analysis, not in the field of epidemiology. The question that you asked is actually a question about epidemiology. And I don't have expertise on this, so I shouldn't opine on this. All I will say is that yesterday or day before, Dr. Soumya Swaminathan, the chief scientist of the World Health Organization, she gave a very thoughtful interview on the third wave. And she's a doctor and a scientist, unlike me. So I'm just reproducing what she says. She says that it's seeming likely that the COVID pandemic may be moving from being a pandemic to being an endemic in India, i.e. that I think the sense is that because infection rates are already so high at 70%, and that vaccinations are increasing very rapidly, it's possible now that it's not going to be like a pandemic, but something over time that will become like flu or influenza, local outbreaks, some deaths, etc., and that it's like going to become much more a part of our normal kind of health and death situation than having the scale of a pandemic. So that's her view, and we should take it very seriously. And so I think an implication of that is that, and this is in her words, that maybe we can be a little bit more optimistic about a third wave because of this, But you should read what she said because she's the scientist, not me.
Thank you. Dr. Kelkar, would you have any comments on what has transpired?
No, Professor Kemberby, I don't have anything to add. But only my appreciation of this very great deal of data-driven work, because that is what is required for the policy making, is a better understanding of data and important data. So I just want to thank Professor Subramanian for this presentation.
There are two questions. One from Mr. Vilas Rajwade. Do we need to revamp our data collection and reporting system over the next few years or so? And if so, how should we be going about this? How should we be going about the same?
Yeah, I think that's a very very key and obvious implication of this work. That we need to absolutely improve our data systems on this. You see, again, I don't know enough about this, but it seems to me that again it's an area for, I think, cooperative federalism, where both the central government and the states I think should come together and coordinate much better, because we have the central system, which is the SRS. We have the state systems, which is the CRS system as well. So I think a lot more resources, a lot more coordination between center and states would be, I think, very absolutely essential for this. And this, and again, remember that the beauty about India is that there are places where these things are done reasonably well. For example, Kerala, for example, its death registration system is pretty good, although even in COVID, maybe a little bit has been affected, but it's very good. Tamil Nadu also is reasonably good. So there are models within India that I think can travel elsewhere as well. My suspicion is that if we improve our health systems more generally, our health measurement systems will naturally improve as well. But that's a much bigger task. So then the question is that independently of that, should we focus on health measurement systems? And I think we should, both in terms of resources, attention, capacity, learning from each other, center-state coordination much more.
There's a question here that I can see from Niran Sajid Philip. It says, what do you consider as the best strategy for TPR estimation? In Kerala, the tests are mostly focused in regions where the infections are clustered. Some think that TPR should be done randomly. What do you think?
Yeah, again, this is slightly beyond my scope of expertise in terms of, you see, in the early stages of the pandemic, I mean, the motto was, test, right? I mean, because early on we thought we have to test and trace, therefore testing became very important. So I think if resources are limited, then I think, the epidemiologists and the scientists should maybe figure out a way of what is the best way of testing. But it seems to me that this is one case that we should be testing, very widely and kind of all the time. So in that sense, it shouldn't be where should we test and when should we test, but testing should be very, very frequent and freely available because that helps us deal with the pandemic. So it shouldn't have to become a case of choice. Should we prioritize some over the other? That only arises if there are resource constraints.
Abhay, do you see any more questions?
Just one question, sir. Mr. Shirish Darak wishes to know, is the mortality data available in public domain? Which I think, sir, your paper would be available in the public domain, I would think.
Our data is available in the public domain. So let me be, the civil registration system is now out in the public domain, CRS. The data that we have on the seroprevalence is now publicly available. Well, whatever the government has put out. The infection fatality is publicly available. The CMIE data itself is a proprietary data, the CPHS. So that we have only put out the code for that. The code is available, but to run the code on the data, you have to have access to the data, and that's proprietary data.
Professor Kembavi, we have just a few more minutes to go. So would you have your closing thoughts, please?
Not very much, because the talk has been so good that I don't want to dilute it by saying inane things. But I feel that one should reflect upon what has been said. And that should be very widely done, meaning even policymakers need to read these papers and listen to them, or have those papers very well summarized, because these opinions are very important, because they affect millions and millions and tens of millions of people. And they also give us some insight on what may happen in the future. Right? So, I mean, we can't be absolutely sure, just like we can't be absolutely sure about the numbers. But we probably should be convinced by now that the story is much worse than we thought it was. Okay, so I should reflect on that point and do our bit for it. I don't want to say anything more than that. I just would like to thank Dr. Arvind Subramaniam for such a nice talk, and we hope to be able to engage with him again. And I'd also like to thank the PIC, Dr. Vijay Kelkar, and others who have organized this session. It was very well done, and I'm sure that all of you must have taken a lot of trouble to do that because it went all flawlessly. So thank you very much, everybody.
And let me also thank all of you for giving me the opportunity to present our work. As I said, the Pune International Center is doing amazing work as a knowledge producing center, as a convening center, policy center, and my hats off to all of you, and of course to my guru Vijay Kelkar. Thank you so much for having me.
Sir, thank you very much for your presence at this event. Thank you very much, Professor Ajit Kembavi. We began this discussion by saying that this has been a landmark study because it set to rest all the doubts that we had about the official data on mortality. And so you began by speaking about the work done by civil society and journalists. And I come with a journalism background. And in the first wave itself, we could see the stress on the burials and the burning ghats. And later we sensed that the gravity of the situation would be visible from what is happening in the burning ghats. And that finally, unfortunately, gave the picture and the magnificent study that you have presented. It was a wonderful synopsis, sir, with the two takeaways that you presented about the size of the excess death estimates and the fact that the wave 1 was higher than what was believed initially. With this, I would like to thank you once again. Professor Kembavi, thank you very much for chairing this session. Thank you to our participants for their questions and their participation in this program. And finally, thanks to my backend team, Kiran and Amresh, for organizing this event. With this, I would like to mention our next event, which is on September 4th at 5 p.m., which is a continuation of our series on India and the world's great religions. And our speaker is Mr. Wajahat Habibullah, former bureaucrat and chairperson, Executive Council of the Commonwealth Human Rights Initiative, India. He will be speaking on India's Islam, a diverse history. We invite you to attend this program. The details will be available on our website. And with this, I would like to thank you for your participation and announce that this program now comes to a close. A good day to all of you. Thank you very much.